Good morning, good afternoon, or good evening. This is a full paper work through of the second mock paper used in January 2025. So the aim of this is to give you a resource for you to check your own work, to identify your own errors, to spot the useful ways to think to tackle these questions. Just like with paper one, I will be having a focus on exam technique and a focus on trying to spot when your answer is correct and when your answer has an error in there somewhere, for you then to recheck your working very carefully. We'll go for the name this time of Mr. Scheme, first name Mark. So let's get straight into it. I've got my calculator to the side. Page 2 is always the formula sheet. Know what's on there, know that you can use that at moment's notice. And we're into question number 1. Right, 1400 is a product of primes, product of powers of its prime factors. So I like to use what's called the factor tree. Some people use what's called the factor chimney. Whichever technique you've learnt, use it. In my technique, I'm looking for numbers which multiply to this. I'm going to go with the 14 and 100. That's quite a nice combination. Every time I can split a number I'm going to, that 14 can split into 2 times 7, both of which are prime. So I'm going to circle them, and they don't need splitting any further. The 100, again, you could do 2 and 50. I'm going to go with 10 and 10. Neither of which are prime, so I can keep splitting. 10 is 5 and 2, both of which prime. And what a surprise, there's another 10, which is exactly the same, 2 and 5. But now we need to write our answer. Now, reading the question carefully, it does say a product of powers. So we're going to write this as a multiplication, and we're going to write it with powers, rather than just lots of 2's. Here I've got 1, 2, 3 2's, so I've got a 2 cubed. I've got 2 5's, so I've got 5 squared, and a single 7. So written as a product of your prime factors, we've got 2 cubed times 5 squared times 7. Now, the question did say that you had to show you're working clearly, so this is what you'd have to do. But for those who want to be a bit sneaky or want to check their answer, there is a button on your calculator that will answer this question for you immediately. So if you type into your calculator the number, press equals so that it's then stored in the display, there is a button on the third row down that says fact. The button has this symbol normally with yellow fact written just above it, and if when that 1400 is stored in your calculator, you hit shift and that button, the display would then read the prime factorization. And now you know you've got the answer right. Now, be warned, if all you write is this side of the line, you will get no marks. Because the question told you to show that working clearly, you have to show those steps which lead to that answer. But there is nothing stopping you from using that trick to check your answer at the end. Question 2 is a transformations question. Describe fully the transformation that maps shape A onto B. We have 4 transformations: translate, reflect, rotate, and enlarge. If we think about what each of those do, can't be an enlargement, they're the same size. Can't be a rotation or reflection because they're the same orientation, they're the same way up. So this is a translation. So our first mark is by using that official term. It is a translation by, and to describe a translation we have to describe it as a vector, a left-right movement and an up-down movement. So if I pick my favourite corner, I'm going to use the one down there, and I want to count to the same point on B. So that's 1, 2, 3 across. So my top number is 3. And it's going to be 1, 2, 3, 4, 5 down. Now downwards will be a negative. So it's a translation by 3, negative 5. Part B of the question on the grid above, rotate shape A 180 degrees about -1, 0. So first thing I'm going to do is I'm going to label that -1, 0, 180 degrees about that point. Now, probably the easiest way to do this question is with graph paper. Put your graph paper over, draw the shape A onto it, put your pencil at that point and spin it round 180 degrees. You don't have to use graph paper. Without graph paper, what I like to do is draw myself an L shape towards the corner, and then it's much easier to visualize what that L shape would look like if it rotates round 180 degrees. This L shape was 3 then 1, which will go 3 then 1. So that bottom corner would land over here. Problem with this method, of course, it requires quite a bit more visualization. And if you do have that visualization, then this question can be done comfortably and you can convince yourself quite quickly that that would be your answer, or learn how to use the tracing paper to get exactly the same solution without having to visualize quite so deeply. And question 3. Here's a list of 4 numbers written in ascending order. So that's actually quite important. So x is smaller than y in particular. X and y are integers. The numbers have a median of 12.5. So that means the middle here is 12.5. Well, that's a bit awkward. Maybe I don't need to set up an equation yet and the other statement will help me. I could set up an equation, but being question 3, I don't think I should. The other statement is we have a range of 4. Well, that says that the difference between the smallest and the largest is 4. Oh, well, I already know the largest. If the largest is 15, then the x, the smallest, has to be 4 less than that. So x would just be 11. Well, that now makes the median a lot nicer. 12.5 is in the middle of 11 and y. Well, lots of ways to think about it. 11 to 12.5 is an extra 1.5. Well, if that's in the middle, it has to go an extra 1.5 on the other side. And 12.5 plus 1.5 gets me to 14. Now, that is done. If you do want to check that work, it's worth writing them out properly and just checking the things do work. Does this have the correct range? Yes. 15 minus 11 is 4. Does this have the correct median? The middle of those, if you do in your calculator 11 plus 14 and divide that answer by 2, you do indeed get 12.5. So those two facts do indeed work, and we can be confident of that answer. Question 4, our set theory question. We have our universal set being the numbers from 1 to 10. That simply means we're only allowed to use the numbers 1 to 10. We can't use anything else in this question. The set A is factors of 6. Useful to actually write what that is. Factors of 6, anything that goes into 6 perfectly. 1, 2, 3, and 6. And if you are struggling to find them, do them in pairs. 1 times 6 is 6 and 2 times 3 is 6. Set B, we can do the same thing. These are our prime numbers. Our prime numbers from 1 to 10 are 2, 3, 5, and 7. So now, rather than having a descriptive definition of A and B, we actually know what A and B are. We now want the union. Now the union, this U shape, means or. So we're looking to write down anything which is in A or B or both. So this is going to be quite a big set. So let's go through. 1 is in A, so that'll be in the union. 2 is in both, 3 is in both. 5, 6, and 7 are in one of them. 4 wasn't in either, so we're not including 4. Neither were 8, 9, or 10. So the union almost always gets bigger. There's more stuff in there. The union is 1, 2, 3, 5, 6, 7. The little dash, the little dash, means not. So this is asking for what's not in A. And remembering we're only allowed to use the numbers from 1 to 10. We've got 1, we've got 2, we've got 3. We don't have 4. So 4 is in this complement. We don't have 5. We don't have 7, 8, 9, or 10. So the complement, the A dash, is that set there. We have a statement that A intersect. That N shape is the intersection, is the and. So it's that A intersect B, that symbol is the empty set. So really what that's saying is there's nothing in A and B. But if I look back at my A and B that I've written down, there is stuff in both. 2 is in common and 3 is in common. Our character is incorrect. Explain why. 2 and 3 are in the intersection. That symbol means is a member of. So A intersect B is not empty. We found some things which are in both of them. Set C. Set with 4 members. The set A intersect C has 2 things. So there are 2 things which are in A and in B. Remember, A is 1, 2, 3, 6. B intersects C is 2 members. So there's 2 things which are in B and C. But A intersects C and B intersects C have no members in common. So in particular, if I use 2, well, 2 is in A and 2 is in B, so 2 would be in both of those, and that breaks it. So the 4 members of set C, well, from A, I have to choose 1 and 6. If I choose 2 or 3, then I'm going to have an overlap with the B intersects C as well. From B, I have to choose the 5 and the 7. Now, it doesn't matter if you put those in the wrong numerical order. As long as you don't write the same number twice, you're good. And that is indeed a set with 4 members where it intersects with A in 2 spots and it intersects with B in 2 spots, and those intersections don't overlap. Question 5. Question 5 shows the design for a badge which will be made using wire. The circle, it's a circle inside of a square. The circle is touching those points and the area of the square is 81. We want the total length of wire. So we need to find all of the side lengths for this question. Well, the fact that the area is 81 and a square's area is the side length times itself, as both the sides are the same, then each side length of the square, for example AB, will be the square root of 81. Something times something makes 81. So each of these side lengths must be 9. So A to B is 9, B to C is 9, C to D is 9, and A to D is 9. But if we want the total wire, we also need the wire used for the circle. But for a circle, we need either the radius or the diameter. And now once I've drawn that on, that should be fairly clear that your diameter is just 9. And if we want to find the circumference, then we can either use pi d or 2 pi r. Because I've worked out what d is, I might as well just use that. So that's going to be 9 pi. I like to not work out numbers until the very end. So in my follow-up working, I'm going to keep it as 9 pi until I have to right at the end. Now I want the perimeter of this shape. I want the total length of all of these wires. The circle has 9 pi, but I've got the AB, BC, CD, DA, which are all 9. So I've got 4 side lengths of 9. And now I'm going to type that in all in one go in my calculator. Useful to do that. Minimize the chance that you make any rounding, any transcription errors, any copying errors from your calculator down onto your paper, or even just from one line on your paper to the next. Now the question did say, give your answer to 3 sig fig. The third sig fig is that 2, so my final answer, 64.3. There is centimetres already on the answer line. Being a length, we are in centimetres, not centimetres squared. I did something a little bit subtle there, which is worth highlighting. Every time you think you finished the question, it's worth rereading the question to, one, check you haven't missed anything. Chances are everything in the question that is told to you is useful. And 2, to check that you've actually answered the question. It'll be quite tempting to leave your answer as 64.274, but the question wanted it to 3 sig fig. If you reread the question before you turn the page, you'll spot that and not throw away silly marks. Question 6, we're on to some algebra. Solve 2f over 3 equals 4f minus 17. My thought process when I see questions like this, equations like this, is what do I hate and how can I fix it? 2 things in this question I don't like. I don't like that f is on both sides, and I don't like the fact there's a fraction. I hate the fraction more. I'd much prefer everything be nice whole numbers, so my first step is to deal with that, which is to multiply everything by 3. I'm undoing that divide by 3. So left hand side, I've undone the divide by 3, I'm left with 2f. The right hand side, if I times the right hand side by 3, both things get multiplied by 3. So that 4f becomes 12f and the 17 becomes 51. You could imagine this quite simply as multiplying the entire right hand side, but you're multiplying the whole thing, you need brackets there, and you're thinking of this as expanding brackets to help you justify that. Well, now I've got f on both sides, so let's try and fix that problem. The normal is to move the smaller amount of f, so to move that 2f. But I've realised if I move that 2f, I'm left with 0 on the left. I'm going to have to do more steps of working, not actually less. So I'm going to do opposite to what's often suggested. I'm going to take away 12f from both sides. Does mean that I'm going to be left with negative 10f equals negative 51. But it also reduces the number of steps I need to do by 1. To get rid of the negative 10, let's divide by it. I missed the negative in my writing. And that you can just do in your calculator. Left hand side, negative 10 disappears. Negative 51 divided by negative 10 is 5.1. And as with every equation, if you want to check your work, you can sub it back in to both of the f's in the original. 2 times 5.1 divided by 3, see what that gives you. 4 times 5.1 minus 17, if that gives you the same answer, then you've got the final answer. There's no mistakes, unless you also make a mistake in that substitution check. Part B, simplify e plus 12 to the power of 0. Well, this is just requiring you to remember what power 0 means. Power 0 means 1. Anything to the power of 0 is just 1. Part C, simplify fully. Notice it says fully. If you miss a little bit of simplification, you will not get all the marks. So let's look at each part in turn. Let's look at the numbers first. 12 divided by 4 leaves behind a 3. Looking at the a's, I've got a to the 4 divided by a with a hidden power of 1. If I divide, I subtract the powers, so 4 take away 1, that's an a cubed. And finally, h to the 6 divided by h squared, subtract the powers again, we're left with h to the 4. There's nothing else I can do to simplify that, that is my final answer. Part D, factorise fully. Again, there's lots of different parts to this question, so let's do each one carefully in turn. Numbers first. Common to 20 and 12, the biggest number that goes into both of those is 4. Looking at the x's, I've got 5 here and I've got 3 here. In common, I have 3. Looking at the y's, I've only got a singular y here a y to the 4 there, so the only thing in common is a singular y. So now I need to try and work out what's left behind. Again, for each term, I'm going to do each number and letter separately. The 20 we've divided out, we've factored out of 4. That leaves behind 5. 5 times 4 makes the 20. If I had x to the 5 and I've lost x cubed, then there's x squared left. I had a y, I've lost a y, being on the outside of the bracket now. So the y's have all gone. First term, done. There's a plus in the middle, I'm going to keep that. 12, we've lost the 4. Be careful if you think about that as a subtraction, it's a division on factorising, so we're doing 12 divided by 4. We had x cubed, we've lost x cubed, x is all gone. We had y to the 4, we've lost a single y, so we go down to y cubed. If you want, there's, again, with algebra questions, the checking is a little bit more difficult. There's no intuition to go with it, but you can expand that bracket back out. If you get the original question, fabulous. If you don't, you've made an error somewhere. Move into question 7. Some more indices work. The left-hand side looks complicated. The right-hand side looks like it'll tell us what the n is. So let's deal with the left-hand side. 3 to the negative 2 times 3 to the 5 over 3 to the 10. You'll be tempted to type that into your calculator, but that won't give you anything useful. So instead, let's use our rules of indices. 3 to the negative 2 times 3 to the negative 5 is adding the powers. Negative 2 plus 5 is 3 over 3 to the 10. Don't be tempted to change that base number. All the rules of indices, that base number, in this case the 3's, do not change. Now when I divide, I subtract the powers. We do the 3, take away the 10, leaves negative 7. But that's the same as the other side, the 3 to the n. So just looking at the powers, the only possibility for n is that negative 7 that we see on the other 3. And now you can actually check this with your calculator. If you do type this in, see what it gives you, and also type in 3 to the negative 7. If those two things give you the same answer, then you're correct. Question 8, percentages. In a sale, all normal prices are reduced by 17%. The sale price of a fridge is 6,225. Work out the normal price. Well, reduced by 17%, that's a decrease. If you start with 100%, you lose 17%, you're left with 83. 83 as a multiplier is 0.83. Working out the normal price implies we're going back in time. If you're going back in time, then you're going to be doing a divide rather than a multiply. So putting those two facts together, our attempted solution is the 6,225 divided, because we're going back in time, 0.83, a decrease by 17%. The answer comes out as 7,500. Being a nice number, that's a good hint you've got it right. And also the fact that the question didn't tell you how to round is a subtle hint that you should be getting a nice round number. So 7,500. And if you wanted to check that, you could try doing the question forwards. Normal price is 7,500. Reduce that by 17%. Do you get 6,225? Yes, indeed you do. 3 marks for that question, which is quite generous for only one calculation, but you do have to acknowledge both the decrease and the division rather than multiplication. Question 9, some standard form. Write that as an ordinary number. Well, that's a positive power, so my answer is going to be big. So the power of 5 tells me that I need to be moving 5 spots. So that's 1, 2, 3, 4, 5. Now there are 3 gaps. Each of those gaps fits a 0 in. So it's going to be 6, 0, 4. And the 3 extra zeros on those extra jumps that we made. And the decimal place is now hiding at the end, but we don't need to write that. Again, you can cheat in your calculator. If you type in 6.04 times 10 to the power of 5, your calculator actually gives it you as an ordinary number immediately. as that 604,000. It won't always do that. It won't always give you the answer as a proper number. But if you type both in and they both look the same in your calculator, then you've got there. We now have a small number to put in standard form. Going back the other way, we want to pick a number between 1 and 10. That would represent 0.00007. And the number between 1 and 10 that could represent that is the 7. Times 10 to the power, well, this is how far the decimal place had to move to get to the 7. If we count, that's 1, 2, 3. I didn't want that to be a straight line. 4, 5. I want that decimal place to be behind the 7, so I've jumped 5 spots. It was a small number, so I jumped 5 spots, but I need to make the power negative. Part C. Work out, give your answer in standard form. I'm going to briefly cheat and look at the number of marks for this question. It's only 2 marks, which together with the way the question's worded means you don't need to show any working. You just need to get your answer. You could do this without cheating with the calculator, but the question didn't tell you to show your working clearly. It just said do it. So I'm going to type that fraction exactly as written in its entirety straight into my calculator. The 7.6 times 10 to the 10 on the top, that's subtraction on the bottom, and the calculator immediately gives me an answer of 200,000. And now this is why this is worth 2 marks. The answer wants to be in standard form. That is not in standard form. So let's put it in standard form. A number between 1 and 10 to represent that is just the 2. How many jumps did I have? 1, 2, 3, 4, 5. I had 5 jumps to put the decimal place from the end into the right spot. It's a big number, so those 5 jumps are going to be a positive power of 5. And again, you can type in 2 times 10 to the power 5 in your calculator, and it will give you that 200,000 that we were hoping it would be. Standard form question done. Question 10. We have a hexagon. Basically looks a bit like a house here. We have the angle BCF. We have loads of side lengths given to us. And we've been told that AB, CF and DE are parallel. We want to calculate the area of this shape. With compound areas, the best way to tackle it is by splitting the shape up into things that you know. So if I split along the dotted line that's conveniently given for us, I've split this shape into a trapezium on the top and a rectangle on the bottom. So let's work those two out. The rectangle seems quite easy. So CDEF is a rectangle of height 4.7, of base 23. One thing that you should check, at least mentally, is the units were the same. And yes, indeed, both of these were in centimeters. So I can go ahead and type that into my calculator. That's 108.1 centimeters. Notice the question didn't tell you how to round, so we're looking for an exact answer here. So far, that is exact. Now the top bit is a trapezium, which needs the sum of the parallel sides. Well, that side is a 23 as well, but it also needs the height, the difference between them. So I need this height here. Well, that's a bit awkward because I don't know that yet. It's not 5. It's similar to 5. And just like with the 3D trig questions, I like to draw out any triangles that I'm using separately in a really obvious way. So I'm going to pick out that triangle there. I've got the angle of 30 and I've got a side length here of 5. And I would quite like that side, the height of this trapezium. Well, now this looks like trig. We have the opposite. We have the hypotenuse. If I have the opposite and hypotenuse, I'm going to use SO. I want the opposite. So if I cover it up, it looks like I should be doing the sine times the h. So the h is equal to the hypotenuse multiplied by the s. The s stands for sine of the angle. If I type that into my calculator, 5 sine 30 gives me 2.5, which again is quite convenient. Trig rarely gives you nice exact numbers. This one has. Really good, because the question is implying that we should have nice whole numbers. So now let's try and work out the angle of the area, of ABCF, the trapezium. Well, that formula is given on the front of your formula sheet, and it is half the sum of the parallel sides, half the 11 plus 23, multiplied by the distance between them, which is the h we've just worked out. So if I do exactly that, a half of 11 plus 23, close the bracket, times 2.5. I've written exactly what I've written down there into my calculator. Gives you 42.5 centimeters squared. You may be screaming at the screen that I missed the squared on the previous one. Good job if you were. So you've got the area of the two separate parts. If we want the total area, let's just add those together. The total area is 108.1, 42.5. Now you might think it's excessive to write down each of these steps. Yes, it is, but I'm making it 100% certain that the examiner cannot drop me any marks for any reason, because I made everything super clear. It's worth considering, does that seem reasonable? If you have a 23 centimeter base, this is 4.7 plus a bit more. Well, we know what the bit more is. It's 2.5. We've got a height of maybe about 7 or 8. We've got a base of about 20-25. Yes, 150 does seem like a very reasonable answer. If the answer came out as 1,000 and something, that's not reasonable. You should notice that there is an error somewhere. You just then need to go and find it carefully. Question 11, a cumulative frequency. Part A is just to draw it. Notice the question's already given us the CF. We don't need to go and find it with an extra column, so we're actually just plotting points. The first point to plot, after 5 hours, we've got a height of 6. So 5 plotted with 6. Remember, we're plotting the end points against those CFs. 10 is at 17. Notice that we're going up in 10, so each little box is going up in ones. 15 is at 27, so that's 2 above the middle of 20 and 30. 20 is at 42. 25 is at 50, 1, 2, 3. And 30 is at 60. Now you don't have to, but a good habit is also to plot the lower limit, the lower part of that inequality. At the lower part, you're at 0. So you don't have to, but you can plot 0, 0 as well. Now in the exam, you should join these up with a nice smooth curve, pencil ideally. Mine's not perfectly smooth. You can see it wiggles in a little awkward way in the middle, but that would be sufficient. Part B of the question, use your graph to find an estimate for the interquartile range. Interquartile range, we need the upper quartile and the lower quartile. Well, they are at a quarter of the way up and 3/4 of the way up. If 60 is my total, a quarter of 60 is 15. So 15 is where my lower quartile will be. So draw across from there and draw down. Now reading that off, we need to be careful. We have 10 boxes to go from 5 to 10. So each tiny box is worth a half. So that's telling me that the lower quartile is 9.5. You may get a subtly different answer. There is some leniency built into the mark scheme for these questions, but you should be very similar. For the upper quartile will be 3/4 of the way up. 3/4 is at 45, which is here. Trying to make my line relatively straight on the iPad. And then working down all the way. Okay, not really straight, but I'm just following the line. If I go off the line, I come back to it, to there. And that is going to be my upper quartile. That's 2 boxes. Each box is worth a half, then 2 boxes is worth 1. So my upper quartile is 21, my lower quartile is 9.5. So my interquartile range is the upper minus the lower. Do that in your calculator, gives you 11.5. 11.5 hours as my interquartile range. 25 workers spent more than W hours working from home. We need to be super careful because this is a more than. Cumulative frequency is all about less thans. So if 25 spent more than and there were 60 people, then 35 spent less. And that's the figure that I'm going to use. So back to my graph. 35 people spent less than my special figure. So I'm going to use 35 on my how many axis, my cumulative frequency. So at 35, again, I'm going to go across to the graph, collides there, and down to the line. Now that's going to be 15. Each 2 boxes is worth 1. No, I did not want that to be a straight line, thank you. So that's 15, 16, 17, 18. That figure there is 18, which means that 18 people, 35 people spent less than 18 hours. So the W that we want is that 18 that I read. One of the 60 workers is chosen at random. This worker spent H hours working from home. Find the probability that that's between 5 and 10. Well, probability is the number of good things out of the total. Well, there are 60 workers, so the total is going to be 60. How many people spent between 5 and 10? Well, I'm actually going to use the table up here. And that says that 6 people took less than 5, 10 people took less than 10, but of the people who took less than 10, 6 of them took less than 5. So the difference between those two is the number of people between 5 and 10. So what's that? 17 take away 5? 17 take away 6. So the probability that we're between 5 and 10 is 11 out of 60. That's basically doing the find the cumulative frequency method, but backwards. We have the cumulative frequency and we wanted to go back to our original frequency. So instead of adding the next one on, we take it away. Question 12. Looks like a similarity question with embedded triangles. In the diagram, we have some straight lines. BE and CD are parallel. AE is labelled as 10. And CD, that bottom side here, is 1.5 times that side. Well, that's exactly what a scale factor is. That big triangle is 1.5 times bigger than that smaller triangle. So my scale factor is exactly that 1.5 being quoted. I do want to get rid of the horribly drawn triangles. We want to find the length of ED, so we want to find this bit here. Well, I can find the whole of AD by using that scale factor to scale up AE, the 10. So the whole of AD is 15. So ED, we need to lose the 10 that we already had. We've worked out that that whole length is 15. So if I lose the 10 that we already had, ED is 5 centimeters. Part 2, we've been told something about AB and BC. And we've been told it in an algebraic way. So AB is 2x plus 5 and BC is 3x minus 5. We want to try and find x. So we need to create ourselves an equation linking these things together. Well, again, it's using the scale factor. If I take the smaller side and I multiply that by the scale factor, I get the long side. Now be careful, the long side is not 3x minus 5. The long side is both of them together. So the long side, if I add those two together, it's actually going to be 5x. The 3x and the 2x, and then the minus 5 and plus 5 cancel each other out. Well, now that's just an equation. Whenever I see an equation, I ask, what do I hate the most? There are brackets. I don't like brackets when solving an equation, so I'm going to expand them out. The 2x times 1.5, you can do that in your calculator, 2 times 1.5 is 3x. The 5 times 1.5, again, calculator will tell me is 7.5 equals 5x. I now have x on both sides. I don't like it, so I'm going to move the smaller amount of x. 7.5 equals 2x. And finally, divide by 2 is 3.75 as my final answer. Now you could leave that as its fraction form, as 15 over 4. Both would be valid final answers. Doesn't really matter which one you go for. Relatively tough. We're starting to get into that middle of the paper where they're starting to ask the questions in less pleasant ways. Question 13. We have a sector of a circle with the centre O, radius R. We've been told the angle is 60. The perimeter is P. Oh, this is going to be nasty. This is going to stay very algebraic. We want to show that the perimeter can be written in that way. And the awkward thing is we don't know what R is. The perimeter, however, is going to be the AO, the OB, and the curved AB. The curved AB is the awkward bit. So that arc AB, you need to remember the formula here. The formula for an arc is the angle divided by 360. That tells you the fraction of the whole thing, multiplied by the entire arc, which is the circumference, which is 2 pi r. Notice earlier in the paper we used the formula pi d because we had d. Here we're going to use the formula 2 pi r, which is the same formula because I have r. Let's simplify that. We have the angle is 60 over 360 times 2 pi r. When I simplify this in my calculator, I'm not going to put the pi there. I want the pi to be left in my answer. So I'm not going to put the pi, but I will do 60 over 360 times 2, which comes out as a third. So my arc AB is a third pi. So my perimeter, I've got a third pi r there. I've got an extra r and another extra r. So if I add all of that together, I've got a third pi r plus r plus r. Simplify that, plus 2r. And look at the question again. Question tells you to give it in the form with a bracket with an r on the outside. Conveniently, r is in both of my two terms. The first leaves behind a third pi, which does look exactly like c pi. And the 2r leaves behind, well, it's going to be the k, leaves behind a plus 2, which is the k. So the c is a third and the k is 2. A nasty question, but just using the skills even though they didn't give you all of the letters. Question 14. Adriana is going to roll a bias dice and spin a bias coin. Bias simply means the probabilities aren't what you expect them, they're unfair. The coin will land on heads with 0.8. You would expect that to be a half. The dice will land on a 6. Oh, the probability dice will land on 6 and the coin will land heads is 0.24. So they've combined some stuff together there for that. Work out the probability the dice will land on 6 and the coin will land on tails. Might be tempted to just take the 0.24 away from 1. Fortunately, that doesn't work because they're not perfect opposites. This actually is a tree diagram question. You can do it without a tree, but I think the tree helps you visualize. So on my tree, I'm going to have the first thing be the coin and the second be the dice. The coin could be heads or tails. The dice could be 6 or not 6. And we need to try and fill this in. We've been told that the probability of heads is 0.8. So the probability of tails is the opposites. Then we can do that 1 minus is 0.2. And we've been told that land on 6 and land on heads, which is the result of this top calculation, is 0.24. And that's all we've got. Well, how would that 0.24 have come about? It's from that branch and that branch. The key factor to remember here is you would multiply to get that 0.24 answer. So 0.8 times something, which I'll briefly call P, will give me that answer, will give me the answer of 0.24. So we actually have to divide in our calculator. If we do 0.24 divided by 0.8, we get an answer of 0.3. So our tree diagram says that that number there had to be 0.3. Well, then the other bit's 0.7. The opposite of rolling a 6 is not rolling a 6. But the dice doesn't know what the coin did, so that exact pairing should be down here as well. And now we can answer the question. The question's asking for the probability that the dice will land on 6 and it will be a tails. So I actually want the tails and 6 branch. But if we're going through a tree diagram, we multiply. So probability of tails and 6 is the 0.2 times the 0.3. The calculator tells me that is 0.06. That's my final answer. Does that seem reasonable? Why is that 0.06 so much less than 0.24? Well, the probability of rolling a tails was so much less than rolling a heads. So she should expect that combination to be much, much less likely. Question 15. We have 3 sides of a regular pentagon and a triangle with some side lengths. We want to try and work out the area of this triangle. Give your answer to 3 sig fig. Implies we're going to do some calculation which doesn't give a whole number answer. Well, to work out area of a triangle, we have one of 2 formula. We either have half base times height, but I don't have the height of this triangle, or we have half AB sine C. Well, it looks like I have an A and a B, but I don't have the angle at C. And this is where the pentagon is going to come in. If I could work out the angle on the other side, or even better, that angle C is an exterior angle. So C is an exterior angle. And the formula for an exterior angle of a regular polygon is really nice. It's just 360 divided by the number of sides, in this case 5 being a pentagon. So that angle C is simply 72 degrees, 360 divided by 5. So now I can jump straight in with the area. The area is a half times one of the sides times the other side times sine of the angle between them, And to type that in our calculator, 0.5 times 6.5 times 3 times sine 72 is 9.2728, etc. I write out more than the examiner wants the first time, and then I'm going to round it to what the examiner actually cares about. 9.27 centimeters squared, being an area. And again, the units are on the answer line waiting, so if you've forgotten your units, you do get away with it here. Does that seem reasonable? Triangle with side lengths 3 and 6.5, area of 9. Yeah. If you do 3 times 6.5 and halve it, if you pretended it was a right-angled triangle, your answer would be very close to this. The fact that it's not right-angled is why it's slightly different. If you got an answer of 30, that would not be reasonable, and you should look for an error. Question 16. We have 6 graphs. We need to try and spot which graph is which. And this is really, do you remember what these shapes look like? The first one, y equals negative 1 over x. 1 over x has the feature of being broken. The graph breaks across 0. And the graph here that breaks across 0 is E. What I mean by breaks is the graph has jumped from being up here to being down here. It's 2 separate graphs. And that's the feature of any 1 over x style thing. Second part is the sine curve. The feature of the sine and cosine curves is they go up and down, up and down, up and down. So this could be A or D. Both of them do that. However, you should remember that the sine curve starts at 0. The cosine starts at 1. The sine starts at 0. So this is going to be graph A. And if you didn't actually remember that, you could just type into your calculator sine of 0. Your calculator tells you that's 0. So if you remembered the waviness, you remembered it was one of these two, you could then just pick a special point. 0 is the easiest to check which one matches that special point. Question 17. Looks like functions. We have an f of x and a g of x, and we've been given that the composite fg equals 2. Well, the composite function, let's deal with that first. The composite fg really means sub g into f. So if I do that, every time I see an x in f, I'm going to replace it with the whole of g. So the top becomes the whole of g, 3x plus 1. The denominator, we had 2x, well now I've got 2 of the g, minus 4. Putting that bracket in there is quite important and quite helpful. I'm going to simplify the denominator, because I know I'm going to deal with this a little bit more later. That'll help me out. So I've got 2 times the 3x, 6x. I've got 2 times 1, but I've got to subtract 4. 2 times 1 subtract 4 gives you minus 2. So now I'm going to try and use the fact to find this k. This composite function we've been told is equal to 2, which means that composite I've just worked out, but with a k instead, 3k plus 1 over 6k minus 2 is equal to 2. And now I need to solve this equation. As with every equation, I ask myself, what do I hate? This is a fraction. I don't like that. So I'm going to multiply up by the denominator. So that's going to stay as a 3x plus 1. And I've multiplied up by the 6k minus 2. Let's expand out that bracket. I don't like brackets. If I can deal with brackets, I'll deal with them. Minus 4. I now have k on both sides. I don't like that, so let's fix it. I'm going to take away the smaller amount of k, the 3k. So 1 equals 9k minus 4. Well, now I just need to undo the layers. Let's get rid of the 4. Let's add it to both sides. 5 is 9k. Let's get rid of the 9. K is 5/9. Not a nice answer. No reason it should have been. But it's unpleasant enough that I want to check it in a very careful way. Well, if I go back to the original problem, if I put K into G and then put that answer into F, I should expect an answer of 2. So I'll do that in my calculator. I'll do 3 times 5/9 plus 1. So I'm doing G of 5/9. 3 times 5/9 plus 1. That a calculator tells me that's 8/3. And then I'm going to put that answer into F and see what happens. Now, because the calculator's pretty useful, I can use the answer button rather than trying to write fractions inside of fractions. So actually in my calculator, I'm going to write answer over 2 answer minus 4. And that does give me my answer of 2 that I was hoping it would be. So although 5/9 didn't look pleasant, it did give me what I wanted. Question 18. Use algebra to show. Do not cheat with your calculator, is what those first few words of that tells me. Use algebra to show. Well, this is our recurring decimals technique. We start by throwing algebra at it. Let x be the thing. The 306, 306, 306. I don't like writing it with the dots here. It hides a little bit of what's going on. So instead I'm going to write it out 3 iterations of the repeating block. The technique is to make the repeating block appear in front of the decimal place. Well, to do that, a 3 size repeating block, we need to move that decimal place 1, 2, 3 spots, which is timesing by 1,000. So that's going to be 306.306. 306. Well, now you'll notice that both x and the 1000x, their decimal places line up perfectly. And for clarity, I will actually write that underneath and line up the decimal places. Well, if the decimal places line up this perfectly, if I subtract these 2 things, all of those decimal places disappear. On the left, I had 1000x and I've lost 1. So I go down to 999. On the right, I have 306, but everything else cancels. The 3's line up, they cancel. The 0's line up, they cancel. The 6's line up, they cancel, etc. All the way down. Everything cancels. But I wanted x. I didn't want 999x, so let's divide by 999. So that's 306 over 999. Because it's a show that question, show the unsimplified fraction first. And then you can type it into your calculator. 306 over 999, it will simplify it for you, is 34 over 111, which is what we wanted. We showed it, we didn't skip any steps, we showed clear algebraic working. If you do want to really solidify it, you can also put what the calculator in my case did, or what you would do to simplify it. To get from 999 to 111, you've divided by 9. And if you do 306 divided by 9, you do get 34. If you really wanted to solidify it to hide your calculator cheating, you can do so. Question 19. We're going on a cycle journey. For the journey, our average speed was 19 kilometers per hour to the nearest whole number. Wasn't sure what the question was until it said that. This is probably bounds. The time is 1.5, correct to 1 decimal place. Work out the upper bound. There we go. So now it's made it very clear that we're talking about a bounds question. A bounds question, I go on autopilot. Step 1, find the bounds. 19 was my speed, nearest whole number. Well, 1 step down will be 18, so 18.5 is my lower bound. 19.5 is my upper bound. My time was 1.5 to 1 decimal place. A step down would be 1.4. So the lower bound is 1.45, upper bound 1.55. We want the upper bound for the distance. Well, what's the formula for distance? Well, speed is distance over time. SDT is a triangle. If you cover up the D, the distance is equal to speed times time. It's worth having at least one mental check that the units match up. Kilometers per hour and hours, yes they do, we're safe. So if I want the upper bound for distance, if I want to go as far as humanly possible, then I want to go as fast as possible, upper bound there, and I want to spend a lot of time doing it. So if I want to go really far, I want to go fast, and I want to do it for a long time, upper bound for distance is the upper bound for speed times the upper bound for time. Let's pick them out, 19.5 and 1.55. I am doing this slowly. I'm showing the examiner very clearly. I understand what I want to do, and I'm showing them doing it. Working that out gives me 30.225, and the question says give your answer to 3 sig fig. So the answer I'm going to quote is 30.2. My speed was in kilometers per hour, so this will be in kilometers. Again, kilometers is on the answer line, so didn't need to acknowledge the kilometers bit. Does that seem reasonable? 19 kilometers per hour in an hour and a half. You're not quite double, but you're close to double. Yeah, 30. Question 20. Solve a quadratic inequality. And not a pleasant quadratic inequality either. 6x squared minus 7x minus 20. To solve a quadratic inequality, you solve the equality first. So I first want to try and solve this equals 0. Now, I'm a big fan of factorizing. This is a horrible factorize, so I'd actually most of the time suggest that you use the formula. Nothing's stopping you in a question like this to just use the quadratic formula. If I am trying to solve this, I've got a 6 and a 20. My 6 could be 6 and 1 or 2 and 3. My 20 has lots of options, or 4 and 5. I'm looking for ways to pair that up that I could then make a 7. I'm not seeing one immediately. We could make, with 2 and 3 and 2 and 10, we can make 6 and 20. That's too much. 2 and 3 and 4 and 5. Yeah, I can make a 8 with those. And I can make a 15 with those. I am using a very magical method here. If you prefer just using split the middle, use split the middle. So this is telling me I'm using 2x and 3x. The 2x has to go with the 4. The 3x has to hit the 5. So they go in opposite brackets. I want negative 7, so I want negative 15, positive 8. Again, I would suggest that you use the quadratic formula. The two solutions here, 2x minus 5 equals 0, will give a solution of 5 over 2. And the other gives a solution of negative 4 over 3. Subtract the 4 divided by the 3. So I've got my solutions. I now want to do a very quick sketch of the graph. The graph has to go through the x-axis at those 2 points at negative 4/3 and 5 over 2. And the original question wants this graph to be bigger than 0. So we're looking for where this curve is above the x-axis, which is that region and that region. We're going to describe those with inequalities. The left branch is where the x values are smaller than 4/3, that side. And over here, we want the values which are bigger than 5 over 2. And that combination of two inequalities is my answer. Nasty question, 4 marks. Do 5 of the questions, and you'll get these marks almost every time. Question 21, a geometry question, or at least a coordinate question. We have a square. A has those coordinates, B has those coordinates. Find the equation of the line that passes through B and C. Okay, so we have some point A, some point B, some point C, some point D. If you're unconvinced of the order of the letters, A, B, C, D as a square tells you that you should be labelling A to B to C to D in a clockwise fashion. We have the coordinates of A and B, and the important thing is AB is a square, so AB is perpendicular to BC. Very important because we know how perpendicular gradients behave. If we want an equation of the line through B and C, we need to know the M and we need to know a point. Well, actually, the point is easy. The point is just B. We know that B is 3, 5, so we have the point. The gradient is a bit harder. We can work out the gradient of AB, and the fact they're perpendicular will help us find out this M gradient. The gradient of AB is the change in Y, 5 take away 2, divided by the change in X, 3 take away -5. Notice that I did it the same order. These two coordinates are the B coordinates, these two coordinates are the A coordinates. If I do B minus A on the top, I need to do B minus A on the bottom. Typing that into my calculator or just working it out is 3 over 8. So the gradient of AB is 3 over 8. The perpendicular gradient, which is the one that I actually want, which is the gradient of BC, perpendicular gradients is a negative reciprocal. Swap the sign and flip it over. So the gradient that I actually want is -8/3, and I have a point 3, 5. So now I can use my favourite, y minus y1 equals mx minus x1. Y minus the y coordinate of the point, which is 5, equals -8/3. X minus the x coordinate of the point, which is 3. Now, notice the style the answer wants to be in. It wants to be equal to 0, and it wants the A, B, and C to be integers. It wants them to be whole numbers. Well, in that case, I hate fractions again. So I want to deal with that fraction fairly early. You could expand the bracket first, but I'm going to deal with the fraction first. So I'm going to multiply everything by 3. So the left-hand side becomes 3y minus 15. The right-hand side, I can expand out that bracket. The over 3 on the outside cancels with the times by 3 that I've just done. So I'm really just multiplying by -8. So it's going to be -8x, the -8 and the -3 becomes a positive 24. The question wanted the answer to be equal to 0, so I'm going to move everything onto the same side. So I'm going to add on 8x, and I'm going to take away 24. -15 take away 24 gives me -39 equals 0. That's my final answer. One easy check that you can do is sub in the point that we think is on the line. If I sub that point in, do 8 times 3 plus 3 times 5 minus 39, my calculator says 0, so that point is on the line. Good, we wanted it to be. Not really much other amazing intuition that you could go for here. Just check your gradient carefully, check the perpendicular gradient carefully, check you've expanded out. The fact that 3, 5 is on it is a really good sign, but it doesn't really guarantee it, unlike some of the other questions where these checking techniques did. Question 22. We have a really horrendous quadratic and linear simultaneous equation. Solve is all we've been told to do. The second one is already y equals. That's good. We wanted that to happen anyway. So in that first equation, I'm going to replace y every time I see it with what the second equation tells me y is. So instead of y squared, I'm going to write the 3x minus 1 squared. Instead of the y over here, I'm going to write 3x minus 1 plus 11. Now that bracket on the right hand side isn't doing anything, but it was a sanity thing. I've replaced the y with something, so I'm going to put it in a bracket. Now I just need to clean up the mess. This is going to be a quadratic in x squared in x, so let's deal with it. Be very careful that this 3x minus 1 is actually 3x minus 1 times 3x minus 1. So you get some inside terms. Don't fall into the trap of just doing 9x squared plus 1. You do get 9x squared. The inside is minus 3x. The outside is minus 3x. So we get a minus 6x in the middle. And cleaning up the other side, the minus 1 and the plus 11 gives us a plus 10. This is now really obviously a quadratic, so it needs to be equal to 0. So I'm going to collect my x squareds on this side. I'm going to move my 3x over. Becomes a minus 3x. The minus 6 becomes a minus 9. The plus 1 minus 10 is another minus 9 equals 0. And again, I've got a quadratic to try and solve. Once again, just like before, I would suggest that you use the quadratic formula. If you want to try and factorize it, you can use the split in the middle. The factorization here will be really unpleasant. I think I've spotted a way to make it work. If we have a 2x and 3, that'll make a 6. And if we have a 5x and a 3, that's a 15, minus 15. And plus 6 will make the minus 9 that I want. I suggest you use quadratic formula. A lot safer, a lot quicker if you haven't got the experience of solving these by factorizing. Solving each of these brackets, you've got 3 over 2 for the first bracket and a negative 5 over 3. Sorry, 3 over 5 for the second bracket. Those are only half the answers. We have the x, we still want the y. So let's use the easy equation. It's still got an arrow to it up at the top, the linear equation. When x is 3 over 2, y is 3 times 3 over 2 minus 1. The pen is slowly running out of power. And if I do that in my calculator, 3 times 3 over 2 minus 1 is 7 over 2. So that would be one pair of answers. 3 over 2, 7 over 2. The second pair is from the other answer when x is negative 3/5. Y is 3 times negative 3/5 minus 1. Type that into my calculator. 3 times negative 3 over 5 plus 1 gives me negative 4 over 5. I lost my equal sign here. So my other pair of answers, negative 3/5, negative 4/5. The really nice thing about simultaneous equations is they've got a really easy check. If I sub those pairs into that first one, they should be correct. So if I do the 3 over 2 squared plus 7 over 2 squared, that gives me an answer of 14.5, which is the same as 7 over 2, 3.5, plus 11. So at least that first pair works. If I do the second one, you need to be much more careful with this one because the negative signs, if I do negative 3 over 5 squared plus negative 4 over 5 squared, putting the negative inside the bracket, I'm getting 1. Oh, uh-oh. Well, that's not correct. Because if that gives me an answer of 1 when I sub it into the left, if I put negative 4 over 5 in the right-hand side, negative 4 over 5 plus 11 is not 1, which means I've made an error. And I think I see that this here looks like an error. I've done 3 times a negative number and I've subtracted 1. that should be really more negative. And if I did go back in my calculator, I put that as a plus accidentally. If I do correct that, then actually this gives me an answer of negative 14 over 5. So if I change my answer line to negative 14 over 5, and now I do the check, negative 3/5 squared plus inner bracket, negative 14 over 5, close the bracket squared, I get an answer of 41 over 5, or 8.2. So this side is giving me an answer of 8.2. Apologise why the question itself is so fuzzy. And if I sub in here, negative 14 over 5 plus 11, negative 14 over 5 plus 11 does give me 8.2. So both of them subbed in give me 8.2 to the left and the right. So that pair of solutions is now correct. Quite conveniently, we made the error there to make it obvious how to then go and find the error and correct the error, and then recheck whether you corrected the error correctly. Moving on. Question 23. We have a graph of x squared minus 2x minus 1, and we want to use that graph to solve x squared minus 2x minus 1 equals 2. Well, I've got the curve. I want the curve to be equal to 2, so I'm going to draw the line on y equals 2. And where they cross is where the solutions to that equation is. So they cross at -1 and at 3. Really nice that they were nice answers as well. The second one, the equation, that looks a bit different. Could be solved by finding points of intersection with something and something. Now, when I do these notes, I have a trick. I do the curve minus the equation, and I've put it 0 equals rather than equals 0 to line everything up. And if I subtract those two things, my answer is what I should sketch. So on the left, I've got y subtract 0, just y. On the right, the x squared minus x squared cancel. Minus 2x minus 5 is minus 7x. Minus 1 minus minus 7. I'm adding 7. It becomes positive 6. So if I wanted to find the solutions to that equation, I could draw the line y equals negative 7x. I don't want to put the x with the a. The a is just the minus 7 plus 6. So I've compared this over here with the answer I got, minus 7x plus 6. Really useful trick for questions like this. If you do curve minus equation, you get the line that you want to draw. Question 24. And we're not even done yet. There is a question 25 afterwards. So this looks like a really meaty question. Diagram shows a solid made from a cone and a hemisphere. The center of the circular face of the cone coincides with the center of the flat face of the hemisphere. Basically saying that that circle at the top is perfectly lined up. The radius of the circular face is x. So let's label that on the picture. The radius here is x. The total height of the solid, S, is 4 times the radius of the hemisphere. So the entire height is 4 times that radius, must be 4x. Well, actually, before I move on, I'm going to do a bit more. I'm not going to even keep reading. Well, that bit there is also an x, because that's the radius of the hemisphere. So the height of my cylinder is going to be 3x. That surely is helpful. Sorry, I said cylinder. My cone is 3x. A separate sphere has a radius of kx. So I've got another picture somewhere of a sphere with a radius of kx. The volume of the sphere is 12.5 times the volume of S. Well, that's where we're going to create our equation. Find the value of k. I'm a little bit worried because x is also an unknown. I don't know k and I don't know x, but I only have one piece of information. Maybe it's fine. So lots of things to do. Our final formula is going to say that the volume of the sphere is equal to 12.5 times the volume of this cone thing, S. So I'm going to end up using that. But let's work out the individual parts first. So the volume of the sphere, well, the formula sheet is at the front, is 4 pi r squared, not squared, cubed. But I know what r is. So this is really 4/3 pi kx. The radius was kx cubed. I'm going to simplify that just a little bit and write it as k cubed x cubed. So that eventually is going to go in that spot there of my final formula, but not yet. I also want the volume of this weird S thing. Well, this S is a hemisphere, which is half of a sphere, and it's a cone. And once again, the formula sheet at the front tells you the volume of a cone is 1/3 pi r squared h. But I need to replace this r and this h with stuff they actually are. I'm also going to simplify. Half of 4/3 is 2/3 pi. Well, the radius of the hemisphere, looking back at my picture, is just x. So that's just going to be x cubed. Plus 1/3 pi. The radius of my cone is just x. So that's an x squared. The height of my cone, I worked that out earlier just on a whim. The height of the cone is 3x. So let's keep simplifying this. Let's hope it becomes quite nice. We're going to have to do some more maths with it later. That bit I can't do anything with. The second bit, I've got 1/3 of 3. They just cancel out. X cubed. Notice I'm avoiding using my calculator. And in particular, I'm avoiding typing pi into my calculator. Probably pi is going to cancel later on. So if you actually work out what 2/3 of pi is, you're making your life a lot harder. Now, if we do look at these two terms, they're both pi x cubed and pi x cubed. Well, this one is 1 pi x cubed. The other is 2/3 pi x cubed. So in total, 2/3 plus 1 is 5/3 pi x cubed. Okay, so now I can go back to this equation that I wrote on the side. The volume of the sphere is this horrible 4/3 pi k cubed x cubed nonsense. The volume of the S thing, well, 12.5, let's not forget that from the question, times 5/3 pi x cubed. And here, two things are brilliant. The first, there's a pi on both sides. Because there's just a pi on both sides, I can cancel it out. Really, I've divided both sides by pi, but I've just crossed them both out. Same with the x cubed. There's an x cubed on the left and on the right. I can just cross them straight out. And that problem that I thought at the beginning, that we didn't know what x was, doesn't matter. X is gone. So what we're left with is 4/3 k cubed on the left. On the right, I'm actually going to work that out. 12.5 times 5/3 is 125/6. Well, I'm trying to find k, so let's undo the layers. Let's multiply through by 3 to get rid of the denominator of 3. So that's 4x cubed. Timesing that in my calculator by 3 gives me 125/2. Divided by 4. You could have done that in one step. You can just do 125/6 divided by 4/3. That would have done the same as those two steps. And finally, I want to get rid of that cubed. So my calculator, I'm going to do the cube root, shift, and the square root button gets you that. 125 over 8, which is actually really nice. It comes out simply as 5 over 2. Now the question said work out the value of k. It didn't tell me to round, so having this as a perfectly nice answer is very, very convenient. So I've got my k. Now that was only part A of the question, which is a little concerning. Normally these questions only have one part, but we have a part B. Only 1 mark though. A solid T is similar, I see the word similar, I think scale factors, to solid S. The volume of T is 512 times the volume of S. Well, that 512 is telling me how to go from the volume of T to the volume of S. That is a volume scale factor. So the volume scale factor is 512. The total surface area of T is D times the total surface area of S. The question is asking, what is this area scale factor? Well, to convert between them, we need to go via the length scale factor. The length scale factor is the cube root of the volume scale factor. Conveniently, 512 is a nice cube number. It's 8 cubed. And then the area scale factor is the length scale factor squared. 8 squared is 64. So this D is simply 64. Only 1 mark for that, which is really harsh, but it is question 24. You have to work harder for your marks at the end of the paper. And question 25, is this the last question? No, there's another one. 26 questions on this paper is really quite harsh. 25, we have a proportionality question. A, R, and T are 3 variables. A is proportional to T squared and A is proportional to R cubed. Well, that's unpleasant. So that's saying that A fish T squared and A fish R cubed. Well, the rest of the question doesn't mention A again. Well, if A is proportional to T squared and A is proportional to R cubed, well, actually, these two would be proportional to each other. So really, R cubed is proportional to T squared. Well, let's turn that into a proper equation. Replace the fish with equals K. So R cubed is equal to K T squared. But I know some values. So let's use R is 0.25 and T is 47. So 0.25 cubed is equals to K times 47 squared. So K is going to be a really horrible fraction. 0.25 cubed divided by 47 squared is 1 over 141376. Horrendous. Find R. Well, let's actually write this back into the formula. So R cubed is equal to T squared over this horrible number. So now I actually want to solve for R when T is a different value. So when T is 365, R cubed is equal to, well, now T is 365, that's 365 squared over horrible nonsense. Let's hope this simplifies at least relatively nicely. And it doesn't even come close. Calculator can't give that to me as a nice number. So that's 0.942 ... I don't want R cubed, I want R, so I'm going to cube root that. Remember, shift and the square root button. Shift square root answer I've typed in. And that gives 0.9804. Question wanted it to 3 sig fig. 0.980 is going to be my final answer for R. Harsh question. Not easy whatsoever. 4 marks, very justified. The numbers are not pleasant. Not really any intuition we could go for here, other than the fact that T got a lot bigger, so R got a lot bigger. Not much else we can do other than say that. That's a question that I would check very, very carefully, pretty much do again when you have time checking at the end. Question 26. Now this is my last question. We have the total marks at the end. So we're on to the final question, and it's not nice. We have a horrible algebraic fraction simplification. They have been a little bit nice in splitting off the whole of the second part in a big square bracket, almost screaming at you, deal with this bracket first. So I am. Hint with algebraic fractions is factorize immediately. I'm actually going to do two things though. I'm going to keep flip change because this was a divide. To divide, you multiply and you flip it over. And I also want to, at the same time, factorize that. Now, unfortunately, unlike the other questions where we had unpleasant factorizations, we can't cheat with the formula. We actually have to factorize it. I'm going to do it in the speedy, cheaty way, which just seems like magic. But if you're more confident with split the middle, use split the middle. Now, one thing that's happened, which often happens with these questions, is a bracket has repeated. We have a 3x minus 5 up on the top here. Really, that's over 1, isn't it? And on the bottom here. Well, if it's in the numerator and the denominator, we can cancel it out. So I'm just going to simply cross out that bracket in both places. And if you were ahead of the game, if you were thinking in a slightly more better way, you could have guessed that one of the brackets of the factorization would have been 3x minus 5 because there's a 3x minus 5 waiting. So now we've got 4 minus 4x minus 1 over x plus 2, which is a much, much nicer looking question. Still not done, still got a way to go, but nicer. We now have a subtraction. A subtraction means we have to have a common denominator. Well, the denominator over here is just 1. So let's use the simplest common denominator, which is x plus 2. If I force that first fraction to have a denominator of x plus 2, I need to make the numerator, adjust the numerator in the same way. So I do that. Simplifying the first bracket, let's expand out the bracket without making a silly error. We're going to have 4x plus 8 over minus the other bracket, the other fraction. There's nothing to do. That fraction's kind of sat there sad, waiting to get involved again. But now I have a common denominator. I can do the subtraction. Now be very careful. We are subtracting the entirety of that numerator. So 4x minus 4x. That cancels out quite conveniently. The numbers, we need to be super careful with this one. We've got 8 and we're subtracting negative 1. If I start with 8 and I lose negative 1, I'm actually adding 1, which gives me 9. So in the simplest possible way, we've rewritten this as 9 over x plus 2. Kind of disappointing how simple it became. A nice thing you can do to check questions like this is pick your favourite number. Sub that favourite number into the original nonsense very carefully in your calculator. Sub that number into your answer. And if both answers match, you probably haven't made an error. Again, that one's unfortunate. It's not a guarantee that you haven't made an error, but you probably haven't. And that's a good way to check your work on some of these horrible algebraic questions where the intuition, the does it make sense question, isn't so helpful. So that is the end of the paper. We've got a blank page at the back. We are complete. Of course, at this point in a real exam, you go through all those points where I said how to check your work carefully, you would do so. All those points where there wasn't a good way to check it with intuition or with any tricks, you would basically look through your working exceptionally carefully to look for any of those numerical slip-ups, algebraic slip-ups, calculator slip-ups. Very easy to type things into your calculator wrong and lose marks because of it. But that is the end of the walkthrough. If you have spotted any errors on my part, please do let me know. I'll attempt to correct them and put them in the description below. Hopefully that was exceptionally useful. We'll give you the ideas on how to do the questions correctly, what kind of thought processes will aid you to get the best possible marks. All that's left to say is enjoy the rest of your day, happy revising, and I'll see you next time.